In this video, we're going to take a look at how to solve a logarithmic equation that has two logarithms in it. Unfortunately, it's going to be much more complicated than the last video. It's actually going to involve factoring and fun things like that, and like in our last video, also checking for extraneous solutions. However, this time we will have some important point, no whining on this one. So there's two logarithms in this problem, which is what makes it more complicated. Now, we did an example in the previous video with two logarithms that was actually very easy, but the difference this time is my two logs are not on opposite sides of the equation. There's that extra 2 in there, which is making this more complicated. So I can't just cancel out the logarithms. Instead, what I'm going to do is condense the logarithm into a single logarithm. So lots of things from previous videos in this example. So both of these are log base 10. I'm going to group this in parentheses. Both of these are log base 10. So recall when we condense, we write the word log one time. Since these two pieces are being added together, they're going to condense using multiplication. So in other words, I'm going to take the 2x and distribute it, multiply these two pieces together. So that's going to leave me with 2x squared minus 10x. So that x squared is where the quadratic part of this is going to eventually come into play, and then equal to 2. So now that I have a single logarithm, now I can use the tricks we talked about in the last video, either exponentiation or simply rearranging the equation into something that does not have a logarithm. So I'm going to write my 10 in there because this was log base 10. Let me just go ahead and rearrange this one rather than exponentiating. So the way we rearranged back when we very first learned logarithms, this is my base, so 10. We raised it to this power over here, so 2. And then we said that would be equal to whatever this part was, so 2x squared minus 10x. So no longer something with an exponent, but we do have something that's quadratic. So let's rewind our brains back to the previous unit where we talked about solving quadratic. So we want to be equal to 0. So I'm going to go ahead and take that 10 squared, or 100, and just subtract that to the other side so I'm equal to 0. So I've got 0. Oops, that's a bad 0. 0 equals 2x squared minus 10x, and then minus 100. Now at this point, if you want to use your calculator and use the quadratic formula, you can. I want to review factoring. It's coming up in the next unit anyway, so I'm going to go ahead and keep going with factoring. One thing I notice, all of my terms are positive, so I'm just going to divide everything by 2 to make this a little bit simpler to work with. Again, if you're using your quadratic formula, you don't need to do any of this. You're probably done with the answers already. That's fine. So this is now what I want to factor. And then just remembering what I need to do. Two numbers that multiply to negative 50, but add up to negative 5. Are you whining yet? I hope not. I said no whining. Two numbers that do that are going to be x minus 10. And then x plus 5 as my two factors, which then means my two possible answers are either x is equal to 10 or x was equal to negative 5. Now before I can just circle both of these and say hallelujah, finally this awful long problem is done, remember I do need to check these for extraneous solutions. I can't do the logarithm of anything negative or 0. So I need to check both of these back in these original parentheses and see if I come up with a negative or 0. Plugging 10 in is fine. 2 times 10 is 20. I can do the log of 20. 10 minus 5 is 5. That's positive. I can do the log of 5. So 10 works. 10 is a great solution to this problem. However, watch what happens with negative 5. As soon as I plug negative 5 back in for x, right here I've got a problem. 2 times negative 5 is negative 10, and we can't do the log of something negative or 0. A similar thing would happen over here. So that negative 5 will not work. I have to cross it out. It's an extraneous solution. The one and only answer to this question is just 10. Wasn't that fun?